been 50 years since we landed on the moon. Imagine living there. One moon day would last about 14 Earth days, and then the freezing nights would last the same length of time. You could Earth gaze, sit and watch the Earth spinning on its own axis, slowly waxing and waning. But what about outer space? What does that look like from the moon? Welcome to Science with Steph, the show where I think way too much about the world around us and then share the best bits with you guys. So this week I'm going to be comparing what space looks like from the moon to how it looks from the Earth, and look at the reasons as to why we might want a lunar observatory. So firstly, let's look at what space looks like from Earth. Now, if you've ever experienced really dark skies, you might have been blown away by the number of stars you can see. The purple streaks of the galaxy, stars twinkling. Maybe if you look for long enough or hard enough, you might start to see shooting stars as well. Now, this twinkling that we see of stars, it's actually called scintillation in astronomy, is actually an effect due to Earth's atmosphere. Trying to observe stars closely is a bit like trying to read writing at the bottom of a swimming pool. The amount of turbulence that the atmosphere creates makes it really hard to make precision astronomy. This can cause a real problem on Earth. Imagine you're trying to precisely measure the width of a star and that width keeps on changing because of the turbulence in the atmosphere. Not exactly helpful. Some observatories on Earth use adaptive optics. The most famous of these is the Keck Observatory in Hawaii. Now, instead of having one big collecting mirror or lens, the Keck Observatory has a whole array of individual mirrors. What they do is when they've decided what part of the night sky to look at, they shoot a laser into the direction they want to observe, then use the reflected signal to work out how much turbulence or aberration there is in the atmosphere. The mirrors then adapt themselves to undo this aberration, so when you get messy, squiggly light entering into the telescope, you get nice, clean, straight light entering onto your imaging surface. On the moon, you don't have this problem. The moon might be a fun place to be, but it ain't got no atmosphere. So when light enters your telescope from space, straight light stays straight. So you don't need any special adaptive optics to unmuddle your signal. It does mean you can't technically sing Twinkle Twinkle while you're on the moon, which is a shame. No atmosphere also means no shooting stars. Most of the shooting stars that we see in the night sky are from little bits of debris and space rock burning up in the Earth's atmosphere. Without that, no shooting stars. Scintillation isn't the only thing that our atmosphere does to light from space though. So you know how we're alive and not burnt to a crisp from the radiation from the sun? Yeah, that's because of our atmosphere. So we've got that going for us, which is nice. Our atmosphere absorbs or scatters a lot of different rays. In fact, the absorption spectrum looks a little bit like this. Radio waves pass through really easily, which is why we always have big radio telescopes listening for aliens in space. But microwaves get absorbed really easily by water particles in the clouds and in the atmosphere, which is why microwaves are a thing and work and warm up your food, which is also mostly water. Actually, leave a comment below if you want me to do a video on how microwaves work, and I have an old microwave that I kind of need to get rid of, and I'm tempted to blow it up, you know, for science, so let me know. Anyway, back to our absorption pattern for the atmosphere. There are small windows in infrared, but really most of that gets absorbed by the atmosphere. Then there is a big window in visible light, which is, you know, really helpful for how we see things. Or maybe we see things because there is a visible window. Mind blown. And then above that frequency, the higher energy, more harmful rays just get scattered away or absorbed by our atmosphere. So while our atmosphere is a really good thing for not burning to a crisp and dying, it does make it somewhat difficult to look at stars and space throughout its whole electromagnetic spectrum. A lot of information can be found out about stars, about their radiation pattern outside the visible spectrum. Take the cosmic microwave background radiation, for example. We can't observe microwaves here on Earth, but through the Hubble telescope up in space, we have observed a pattern of microwaves all across deep dark universe, which is the remnants from the Big Bang. That remnants from the Big Bang tells us a lot about the age of the universe, how hot it was, stuff about the very, very early universe that we would have never been able to detect here on Earth. And for distant stars, we can use their whole spectrum to detect their size, their temperature, their age, whether they have a planetary disk around them, whether they're electromagnetically strong, whether there might be planets orbiting them. Loads of really useful information is lost in our atmosphere. We do have space observatories out of the Earth's atmosphere and in orbit, but they're kind of limited to the amount of equipment that they can hold on them. If we had an observatory on the moon, you're not limited by the amount of equipment you can add. You can keep adding new sensors every time you go and visit the moon. You're not going to be worried that adding a new sensor is going to throw it into some horrible orbit, hopefully. Another advantage of having an observatory on the moon is just the amount of time that you've got to observe things. On the Earth, we have, roughly 12 hours of night followed by roughly 12 hours of day. And so you've only got a limited window of time to actually observe a certain point in the sky. Stars track by 15 degrees every hour, so all our telescopes, or the more fancy ones, are built with mechanical systems to actually follow the stars in the sky. On the moon, one nighttime lasts 14 Earth days. If you can observe one point in the sky and track it over 14 days worth of time, that means more photons hitting your telescope, which means more data, which means more science. You could maybe even detect full events in one night. You are then followed by 14 days worth of daytime where you can't do as many observations, but I still think it's a good thing overall. But what I would love to observe from the moon is just looking back at the Earth. Now, the same face of the moon is always facing the Earth, so if you're on the moon, the Earth wouldn't rise and set with the rest of the stars. It would just be locked in one point in the sky. So you could sit over days and days watching the Earth rotate on its axis. It would also wax and wane in the same way that the moon waxes and wanes on Earth. So you could have, full Earth days and Earth eclipses, and it would be pretty interesting to see. So my question for you is, if you ever got the opportunity to go to the moon, would you do it? And what would you love to do when you're there? I would love to jump and just see how high I could jump because of the lower gravity. Also, I was going to make this video longer and talk about all the different lunar missions that we've had since the 60s, but I felt that this video was long enough anyway, so if you want to see that, leave a comment below and I'll write up that script to make that for you. In the meantime, if you want to watch my last episode, which was actually a podcast with me and my boyfriend talking about our Tinder data, then you can watch this by clicking here, or if you want to watch the video that the YouTube algorithm thinks you'll enjoy best, you can click down here. About here. And if you did enjoy this video, please give a like and subscribe if you haven't already. I have been uploading kind of irregularly, so it's probably worth hitting that bell so you get notified when I next upload. But anyway, in the meantime, thanks for watching and I'll see you next time. Alright, bye! Yeah, you do have things on the hing-mahing. I like that.